Hello everyone, this is Bolaj Vasishta from Aerobic section. Today I'm going to explain about a topic in data structures which is known as evaluating the readability of force directed graph layouts, a deep learning approach. So, according to this, the algorithm should be written in the type of graphs, and the algorithm which we write will be calculating about, and the force directed in the graphs will be shown with a search engine or with a programming engine. Coming to the introduction of this, graphs have been widely used to represent network data from a variety of domains like social networks, biological networks, mobile device connection networks, financial transaction networks, etc. Graphs are often visualized as node link diagrams as to support a variety of network exploration tasks. Accordingly, many automated graph layout techniques have been proposed in the past few decades, five which attempt to optimize various visual properties for graph visualization. For example, the traditional force directed graph layout algorithm builds off a force model to avoid node occlusions and edge crossings. And clustering based graph layout techniques are designed to preserve the cluster structures of nodes. 15. There are also other graph layouts methods that aim to preserve the relative graph theoretical distance of nodes through dimensional reduction techniques. However, it is impossible to optimize all these desired properties in a graph layout, as the optimization goal of some desired properties essentially contradict each other. It means when researchers want to check whether a specific graph layout is desirable, they must evaluate the graph layout from different perspectives. And the related work the related work of a paper can be divided into two categories: deep learning and graph drawing readability metrics. We mainly discuss the representative work due to limited space. A deep learning. So, what is a deep learning? A deep learning has achieved great success in recent years and shown significantly better performance in pattern recognition and image recognition tasks that many previous conventional methods, inspired by the notable success of CNNs, especially their application in image classification and recognition. We propose a novel CNN architecture to learn the latent features in the graph layout images and further predict their readability values. Since graph layout images usually show more apparent and relatively simpler feature structures when compared with natural images, a very deep network for identifying hierarchical features may not be necessary. Therefore, we followed the vital design principles in VGG 8, and VGG achieves excellent result in learning the features of natural images with a relative show of neutral network, and adopted some other classical CNN designs such as normalization layer introduced in AlexNet. The commonly used ReLU and ALU activation functions, on the other hand, due to internal complexity and non-linear structures of deep neural networks, many visualization researchers have proposed different visual analytical techniques to help people better interpret various deep neural networks such as CNN 12, 16, 20, recent neural networks RNN 14 deep generative models. So, and graph drawing readability. The readability of a graph drawing often refers to how well a graph drawing conforms to desired aesthetic criteria. Prior work has evaluated the readability of graph drawing through either qualitative human concept evaluation and quantitative readability metrics. Example: the minimizing the edge crossings and reducing the occlusions between nodes. So, human centered evaluations usually assess the readability of graph layouts by conducting some user studies and asking participation of participants to finish some graph drawing related tasks. 13 with eye tracking techniques and task oriented analysis used to indicate the task indicate this tracking technique of task oriented. On the other hand, readability metrics defined quantitative measurements to indicate the graph readability. For example, purchasing at 17 investigated 7 common aesthetic criteria in a drawing, and also the both local and global readability metrics in common aesthetic criteria. The calculation of readability metrics is always based on the coordinates of nodes and edges, and also usually not a computationally effect. In the constant of a prior studies, this paper attempts to estimate the readability metrics directly from the graph layouts images by training a CNN model. The work focuses on the estimation of global readability metrics, which is also different from a recent work that targets at the aesthetic discrimination of a pair of graph layouts. Specifically, we choose 10 representative readability metrics to demonstrate the effectiveness of the proposed deep learning based approach in evaluating the graph layout readability metrics. Are 10 types of graph readability metrics are used in our paper. Among them, 3 of them are choosing metrics: node number, edge number, and community number, which can be determined or denoted as NN, EN, and NC, are straightforward counts of visual features which will not be discussed in the section. First one is a node spread NSP. The dispersion of nodes in a graph layout measures the global density of nodes in the layout. We propose a heuristic to measure the node depression, which evaluates average distance of each node from center of its cluster. A smaller value indicates density and a larger value indicates sparsity. Let AC be the set of all communities. Every node belongs to exactly one community in AC. We denote that x and y values of node I and ix are respectively. We denote a mean x value and mean y of all nodes in community, which is NSP, which can be given as sigma of 1 by c 1 modulus of c belongs to into the summation of root of mu x c minus ix2 into 2 by plus mu ic minus iy into 2. And node accumulations. Node accumulations is the sum of all instances of nodes being positioned at the time coordinate within a threshold of closeness to compute NOC. We liberate over or iterate over a node pairs, and we have edge crossings, which can be used to make graph look like cluttered and obfuscate information with internode relationships. And we have minimum angle. Minimum angle was originally defined by purchase of a average value of absolute mean deviation of a ideal minimum angle pi of minimum v, and the minimum angle can be determined as the minimum is equal to 360 by degree v. The range of a metric can be 0 to 1, and we can determine the formula as ma is equal to 1 minus 1 of modulus v summation of sigma v minus sigma minimum of v sigma v. And we have edge length variation. Edge length variation is a deviation of edge length from its mean value, and can be determined with the formula of a root of summation of le minus l into 2 divided by modulus of e into lu into 2. And we have the labeling of graph layouts. When rendering the graph layouts of a previous step, we also store the coordinates of nodes and edges. This makes possible for us to compute readability metrics using the methods of described in the background. The matrix sources are used in Training Pro. As we can see, these are the examples of drawing from our data set, in which the augmented labels are the image labels from the background section of a emote sorted from the nodes by NN. And this is the percentage errors which we come across all this NN, NOC, NC, NSP, EN, EC, EO, ECO, MA, MI. And coming to visualization and convolution layers. As a part of a evolution of CNN model, we come across a neuron activation convolution layer. This would allow us to see the layers of a learning features in an input image. So this is the two examples of a input image and corresponding outputs of the first two convolution layers. As you can see, there are convolution layers with different types of graphs in it. So what is the conclusion in the future work which can be done? Traditional quantitative methods for evaluating the graph readability are based on the coordinates of nodes and edges in the graph layout. Such methods require extra space to store the coordinates and usually not computationally efficient, especially when the graph size increases. In this paper, we propose a CNN based model to evaluate the readability of graphs layouts when the readability metrics of a graph layouts are evaluating by using the graph layout result itself. So that we generate the graph layout data set by using the prior representative algorithms and label these layouts images with readability values evaluating through traditional methods of ground truth. Then coming to this, also it is an high achieved language with high level of accuracy and especially for node related readability metrics. So we are supposed to do CNN model and manually labeled real graphic data sets instead of synthetic graphs. Also, we would like to extend the proposed approach of the evolution of other visualization designs such as scatter plots and parallel coordinates, bar chart and parallel coordinates. So, this is all for my explanation. Thank you.